Bismillahirrahmanirrahim. Hi everyone, I hope you are all doing well. My name is Azmat Ali and I welcome you all in class of Elementary Number Theory by David M. Burton. In today's lecture, we will discuss a most general version of division algorithm. Uh, in last lecture, we discussed a standard version of division algorithm that can be stated as lastly, we defined division algorithm as if a and b are two integers such that b is a positive integer, then there exist a unique integers q and r such that a can be written as bq plus r, where your remainder r is bounded by 0 and b. A more general version of division algorithm is obtained on replacing the restriction that b, which is the divisor, must be positive by simple requirement that b is non-zero. Actually, in standard version of division algorithm, we read our b, that is the divisor, must be positive. But is it possible that division algorithm hold when b is negative? Yes, this is possible. And these two both cases can be summarized in uh, general version of division algorithm. So the more general version of division algorithm can be stated as if a and b are two integers with b is non-zero, then there exist unique integers q and r such that a is equal to bq plus r, where your remainder bounded by 0 and b absolute. While in standard division algorithm, your remainder lies in 0 and b. Next, we see its proof. It is enough to consider the case in which b is negative, because the case in which b is positive we have already discussed in our previous lecture. As here b is negative, this implies its absolute value is positive. So the simplest version of division algorithm guarantees that there exists q dash, that is the quotient, and r remainder exist, for which we can write a is equal to b absolute q dash plus r. Because in the standard division algorithm you read if b is positive, then your dividend can be written as b time q plus r, where q is quotient and r is remainder. As here b is negative, but its absolute value will be positive. So now we can define a in this form: a is equal to b absolute into q dash plus r, where r lies between 0 and b absolute. Noting that b absolute is negative, because our b is negative, so by the definition of absolute function, you now x absolute is equal to minus x if your x is less than 0. So here b absolute is minus b. We may take q dash, that is the quotient, equal to minus q to arrive the result a is equal to bq plus r. If you replace here in this equation q dash is equal to minus q and b absolute is equal to minus b, we arrive at a is equal to bq plus r, with r lies between 0 and b absolute. Further, by few example, we can illustrate the division algorithm when b is negative. Let us take my divisor b is minus 7. Then for the choices a is equal to of a is equal to 1, minus 2, 61 and minus 59, we obtain the expression. When a is 1, then the division algorithm says we can write 1 is equal to 0 into minus 7 plus 1, minus 2 is equal to 1 into minus 7 plus 5, If you divide minus 2 by the divisor minus 7, minus 7 ones are minus 7. This gives plus 5. So you can write it as dividend is equal to divisor, that is minus 7, into quotient plus remainder. Let's take the form. Similarly, you can write 61 as upon the division of minus 7. 61 is equal minus 7, minus 7 eights are 56. This is plus 56, and the remainder is 5. And similarly, minus 59 can be written as 9 into minus 7 plus 4. So, in today's lecture, you have learned that it is possible the divisor and both quotient could be negative. So, I hope now you have clear understanding of more general version of division algorithm. So, in the next lecture, we will discuss the problem that is related to the square of the integers. So, take care. Allah Hafiz.